Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss one of the chemistry lessons, redox reaction, part 1. Before we begin today's lecture, we request you to subscribe, like and share our YouTube channel among your friends and relatives. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Let us begin today's lesson. So, before starting the lesson, let us tell you about the structure of this lesson and whom the lesson is for. This lesson is organized in such a way that it starts from a very simple topic, then it moves gradually to the tough topics. Any student who are in 11th, class 11th we have a chapter 8 in ncert which covers this redox reaction. So class 11th student can go through this video. It is guaranteed that you will gain 100% of this chapter without mugging up the chapter. It is also for the students who are preparing for IIT, JEE, NEET or any engineering or medical college examination. The basic concepts are there. In future videos, I'll give more questions for NEET and IIT, JEE or state engineering or medical examinations like in West Bengal Joint, Delhi Engineering College, or in UP we have regional engineering colleges. In Bihar we have BIT, in Jharkhand we have GIT, and in this way it will cover all the exams where redox reaction is in the syllabus. So let us begin the lesson. First, what is redox reaction? Reaction in which oxidation and reduction occurs simultaneously. That is called redox reaction. So we'll go to the details. What is oxidation? What is reduction? For now, just remember that oxidation in same reaction, if oxidation and reduction happens simultaneously, that is a redox reaction. Now we'll get gradually clear those terms like oxidation, reductions, these things. So we have many ideas. One of the ideas is classical idea of redox reaction. So according to classical idea, let us see what are the definitions given. So what is oxidation as per classical idea? So remember, very simple, oxidation means addition of oxygen. First, from the word it is clear that addition of oxygen is called oxidation, or addition of electronegative elements are also oxidation, and opposite to that, removal of hydrogen is oxidation and removal of electropositive elements are also oxidation. Now we'll see examples in each of the case, for each of the case. So first example of oxidation where we explain that addition of oxygen with the reaction. So the reaction is uh, magnesium plus oxygen gives magnesium oxide. Here oxygen is added to magnesium, so it is an oxidation reaction. Clear? Next example, addition of electronegative elements. So what are electronegative elements? First this thing. So in the periodic table, right hand side, for example, halogen groups are all electronegative elements. For example, chlorine, fluorine, bromine, these are electronegative elements. So addition of any electronegative element in a reaction is called oxidation reaction. Now here magnesium again is reacts with chlorine to give magnesium chloride. So initially magnesium was alone, now chlorine is added to form magnesium chloride, so it is a oxidation reaction. Third, removal of hydrogen. So in any reaction, if hydrogen is removed from the compound, then it is called oxidation reaction. For example, H2S plus O2, it removes the hydrogen from H2S and form water. Therefore, it is an oxidation reaction. So removal of hydrogen is happening. So it is an oxidation reaction. From H2S, hydrogen is removed, sulfur is left alone. So it is an oxidation reaction. Now removal of electropositive elements. So what are electropositive elements? So removal of electropositive element are called are oxidation reactions. So what are electropositive elements? In a periodic table, the left hand side, for example, sodium, potassium, these are electropositive elements. So so removal of any of these electropositive elements in a reaction is called oxidation. In the below reaction, we can see uh, potassium iodide. From potassium iodide, potassium is removed. So it is an oxidation reaction. So potassium iodide reacts with chlorine, it forms potassium chloride and iodine is left alone. So in this way potassium is removed, so it is an oxidation reaction. So what is oxidizing agent or oxidant? So according to classical concept, a substance which supplies oxygen. So main thing is any substance which supplies oxygen is called oxidation, or any electronegative elements. So supplies oxygen or any electronegative elements, or removes hydrogen or other electropositive elements are called oxidizing agent or oxidant. So definition is quite simple. Any substance which supplies oxygen or electronegative elements or removes hydrogen or other electropositive elements are called oxidizing agent or oxidant. Now let us see what is reduction reaction. So addition of hydrogen or addition of any other electropositive element removal of oxygen or removal of any electronegative elements are called reduction reaction. So addition of hydrogen or addition of electropositive element, removal of oxygen or removal of any electronegative elements are called reduction reaction. So let us see an example for each of the cases. Addition of hydrogen, that is Br2 plus H2S gives 2HBr and sulfur. So here in Br2 hydrogen is added here. There was no hydrogen here. Hydrogen added here. So it is a reduction reaction. Removal of oxygen. So in this reaction, ZNO, zinc oxide, we have an oxygen here. But in the product, in the reactant, we have oxygen in zinc oxide. But in product, we won't have oxygen. Oxygen is removed. So it is an removal of oxygen, that is a reduction. Next, removal of electronegative elements. So here now removal of electronegative elements. So it will be 3. 2FeCl3 when reacts with hydrogen, it gives 2FeCl2 plus 2HCl. Here total count of Cl is 6. 2 3 is 6 here. But in product we have a total count as 4. So from FeCl3 we are getting FeCl2. So it is a removal of electronegative element. Chlorine is electronegative, of course, electronegative element. So here removal of electronegative element. So it is a reduction. The fourth point. Addition of electropositive elements. So in the below reaction we can see 2HgCl2 aqueous plus SnCl2 aqueous gives Ag2Cl2 solid and SnCl4 aqueous. So in this case in the reactant we have single Ag. Don't take this 2. This 2 is for balancing the equation. But if you see AgCl2 is the element, is the compound. So we have single Ag here. But in the product we have Ag2Cl2. So Ag is increased. One atom of Ag is more here, added here. So addition of Ag is a electropositive element. So addition of electropositive elements is called reduction. Now comes reducing agent or reductant. Like oxidizing agent and oxidant, just it is opposite of that. So what is reducing agent or reductant? According to classical concept, a substance which supplies hydrogen or any electropositive elements or remove oxygen or any electronegative elements are called reducing agent or reductant. So let us move forward. This is pretty simple. Let us see a common example where we will explain the oxidation, reduction in the same reaction, that means in a redox reaction, which is taking simultaneously. And what is oxidizing agent or oxidant, and what is reducing agent or reductant in the same equation. So we have an equation Fe2O3 plus 2 aluminum plus gives Al2O3 plus iron. We have balanced the equation. Now see aluminum. In aluminum, in the reactant there is no oxygen, but in the product oxygen is added, Al2O3. So it is an oxidation reaction. Now in Fe2O3, in the reactant we have oxygen, but in the product here we won't have oxygen here. Oxygen is removed from Fe2O3. So it is a reduction reaction. So in aluminum, again if we see in aluminum, aluminum is a reducing agent. Why? Because it supplies so in this reaction aluminum removes oxygen from Fe2O3. Aluminum removes oxygen from Fe2O3 so that iron can be formed. Therefore aluminum is a reducing agent, because we are saying that anything which removes oxygen, any substance which removes oxygen. So in this case aluminum removes oxygen from Fe2O3, so it is aluminum is a reducing agent. On the other hand, we can see Fe2O3 supplies oxygen to aluminum, to form Al2O3. So Fe2O3 is a oxidizing agent. So it is quite simple. Don't get confused. Just remember this. Go to the basics definition. So according to the classical concept, a substance which supplies hydrogen or any electronegative element or remove oxygen or any electronegative elements is called reducing agent or reduction. So now we are clear with the concept: what is oxidation, what is reduction, what is oxidizing agent, what is reducing agent. In this reaction oxidation and reductions are happening simultaneously. So this is called a redox reaction. So the first topic we have studied a question that what is redox reaction. This is the answer, this with the explanation. Now it is, till now you are clear with oxidation, reduction, redox reaction, oxidizing agent, reducing agent. Let us move forward. Electronic concept of redox reaction. According to the electronic concept, what is oxidation? Loss of electron is called oxidation. What is reduction? Gain of electron is called reduction. So let us see a redox reaction according to electronic concept, how oxidation and reduction takes place. So, and what is oxidizing agent and what is reducing agent in terms of electronic concept. So there is a reaction, redox reaction, which is sodium plus chlorine gives sodium chloride. So in sodium, what is happening, and in chlorine what is happening? So we can see in sodium, sodium gets converted to sodium ion in NaCl. So it is loss of 2 electron. So loss of electron is called oxidation. So here sodium in this reaction, it is a case of oxidation. In chlorine, what is happening? Chlorine was no charge was there, but in NaCl chlorine have negative charge. So for 2 chlorines, so 2 negative charge, so gain of 2 electrons. Since it is gain of 2 electrons, so it is a reduction. Now oxidizing agent and reducing agent. So reducing agent in sodium, uh, we are having loss of electron. So it is a reducing agent. In sodium, loss of electron, so it is a reducing agent. And in chlorine, there is a gain of electron, so it is a oxidizing agent. Always remember oxidation and reducing agent. Oxidation happens in reducing agent and reduction happens in oxidizing agent. But crossly it is true. So oxidation happens in reducing agent, reduction happens in oxidizing agent. For example, in our case, sodium is a reducing agent, but oxidation is happening in reducing agent. Again, chlorine is a oxidizing agent, but reduction is happening in oxidizing agent. Let us move forward. Now let us see a concept called oxidation number. The oxidation number is defined as the charge which appears on an atom of the element when all the other atoms attached to it are removed in the form of their ions. Oxidation number is also called oxidation state. So in simple way we can say that in a compound, if all the other atoms are removed, whatever is the charge of a particular element in that compound is called the oxidation number. We'll come to know more details about oxidation number and how to find it out and all this in gradually in the later section of this chapter. So for now, let us take an example. For example, take NaCl. So if you remove Cl, only Na, what is the charge for Na? It is +1. So this is the oxidation number of sodium. Similarly, if we in NaCl only, if we remove Na, what will be the charge? What is the charge? -1, that is the oxidation number of chlorine. So again, let us go to the definition. The oxidation number is defined as the charge. So it is the charge first of all, which appears on an atom of the element when all the other atoms attached to it are removed. So in the first case we have removed chlorine, whatever the charge left in sodium, that is the oxidation number for sodium. In the second case we have removed all the other atoms, we have to find out the oxidation number of chlorine. So we have removed the other thing, only sodium is there, we have removed sodium. So what is the charge in chlorine? That is -1. So that is the oxidation number of chlorine. Now it is clear. There are few rules to find out the oxidation number of any element in a compound. Let us see those rules. So rule number 1. The oxidation number of an element in its elementary form is 0. For example, that is molecular form. So H2 molecule, oxidation number is 0. O2 oxidation number is 0. N2 oxidation number is 0. Cl2, Na, Mg, etc. all have oxidation number 0. Second rule, in a single monoatomic ion, the oxidation number in the same is the same as the charge on the ion is the same as the charge on the ion. For example, oxidation number of sodium is Na plus, ion is +1. Oxidation number of oxygen in O2 minus ion, O minus 2 ion is -2. So whatever is the charge will be the oxidation number. In this case, sodium have +1, so oxidation number was +1. In the second case, oxygen have -2, so its oxygen's charge is -2, so its oxidation number is -2. So rule number 3. When hydrogen forms compounds with non-metals, its oxidation number is +1. For example, oxidation number of hydrogen in HCl, chlorine is a non-metal, is +1. Again with H2S, it is again +1. So oxidation number of hydrogen in HCl, H2S, etc. is +1. But in metal hydrides, the oxidation number of hydrogen is -1. For example, oxidation number of hydrogen in lithium hydride or sodium hydride or calcium hydride, etc. is -1. So you have to remember this. Rule number 4. The oxidation number of oxygen is -2 in most of its compound except peroxides like hydrogen peroxide, BaO2, etc., where oxidation number is -1. For peroxides, oxidation number is -1. In OF2, oxidation number of oxygen is +2. In O2F2, oxidation number of oxygen is +1. So we have to remember this. Rule number 5. In compounds of metals and non-metals, metal atoms have positive oxidation number while non-metals have negative oxidation number. For example, in NaCl, oxidation number of Na is +1 and oxidation number of Cl is -1. In compounds of metals and non-metals, we have to understand the metal atoms have positive oxidation number and non-metals have negative oxidation number. So in NaCl, the oxidation number of sodium is +1 because it is metal, and chlorine, it is non-metal, so it has negative oxidation number, that is -1. So rule number 6. In a compound with two non-metallic atoms, the atoms with higher electronegativity have negative oxidation number and the other atom have positive oxidation number. For example, in HCl, oxidation number of hydrogen is +1 and chlorine is -1 because chlorine is higher electronegative element. So its oxidation number will be negative. And the other element, hydrogen, its oxidation number will be positive. It is low. So chlorine having higher electronegativity have negative oxidation number. So in neutral compounds, rule number 7. In neutral compounds, the sum of oxidation of all the atoms of different element is equal to 0. So take any compound, for example NaCl, its oxidation number is sum of sodium and sum of oxidation number of sodium and sum of oxidation number of chlorine, which will come to 0, that is +1 and -1 is equal to 0. Similarly, in any neutral compounds, the oxidation number is 0. Rule number 8. In complex ions, the sum of oxidation number of all the atoms is equal to the net charge on the ion. For example, sum of oxidation number of N and H in NH4 is +1, which is equal to its charge. So these are the 8 rules. By following these 8 rules, we can find out the oxidation number of any element in a given compound. Let us see few examples how to find oxidation number of different elements in a given compound. So this question, few examples. In finding out the oxidation state or oxidation number, these questions are little difficult questions. For IIT, JEE, NEET and other competitive examinations. Let us see the first question. Determine the oxidation state of sulfur in Na2SO4 O6. Options are A +3/2, B +5/2, C +half, D +2. So let us see how we'll solve this. So first, don't see the answer. First we got it B as a correct answer. So but how? Let us see. Oxidation number of sodium is +1. We know that, and the rule also it is given. Oxidation number of oxygen is -2. This is also known. So we have done here some correction. Question is Na2S4O6. That was a typo error. So oxidation number of S is X. We have kept it as X. Now 2 atoms of sodium, so 2 multiplied by +1 plus 4 multiplied by X plus 6 multiplied by -2, and the molecule is neutral, so the summation of all the oxidation number of its element is equal to 0. On solving, we get X is equal to +5/2, but this is not the answer. We have to understand again. So to find out the complete answer, it is again explained. We have to find the value of average oxidation number for S. How to do that? First we'll draw the structure for Na2S4O6. The structure will be in this way. Here the important thing is 4 coordinate bond between S and O. 1, 2, 3, 4. And rest of the bonds are covalent bonds. Fine. The oxidation number for each S atom forming coordinate bond is +5. So how many covalent bonds are there? So 1, 2, 3, 4 and 5. 5 covalent bonds are formed with S atom to its neighboring atom, and 4 coordinate bonds are formed. So the oxidation number of each S atom forming coordinate bonds is +5, whereas oxidation number of each S atom involved in covalent bond is 0. So here we put average oxidation number as +5 +5 O +0 upon 4. Upon solving we get +5/2. So we have 4 covalent bonds, 4 coordinate bonds, and each coordinate bond, the oxidation number of sulfur for each coordinate bond is +5. So it is divided by 4, and in both the cases it is +5/4. So, and for pure covalent bond we have 0. So if we add this thing, we'll get +5/2. This is the average oxidation number. This was the question. In our case it is same, but in different cases it might be different here. So here we have already found the x is equal to +5/2, and after drawing the structure, taking the coordinate and covalent bond into account, also it is +5/2. But this is the correct way to proceed the sums. Next question. Find the oxidation state of N in NH4NO3. In NH4NO3 we have 2 nitrogen atoms. Oxidation number of N in NH4 plus as negative oxidation number, and oxidation number of N in NO3 minus has positive oxidation number. So therefore we can find the oxidation number separately. So oxidation number of N in NH4 plus is x plus 4 multiplied by +1 is equal to plus 1 and x is equal to minus 3. Similarly, oxidation number of N in NO3 minus is y plus 3 multiplied by minus 2 is equal to minus 1, y is equal to plus 5 upon solving. And this is the end of today's class. Before we close our session, we request you to subscribe, like and share our YouTube channel among your friends and relatives. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded. Thank you for supporting us and watching our videos.